Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Gaylord National Harbor Convention Center right outside Washington, D.C., where we're covering the Air Force Association's annual Aerospace and Cyber Conference and Trade Show. Our coverage here is sponsored by L3 Technologies and Leonardo DRS, and we're here with Cobham, the UK part of the innovative British firm, and my friend Greg Caires, one-time co-worker when we were both at Defense Daily, and you're now the spokesman of the company. Greg, great to see you.
Nice to see you, Vago. How are you?
It's absolutely great seeing you. You guys always have very interesting technology that, like everybody here, but you guys in particular tend to focus on certain discrete and select problems that you guys try to tackle. The whole issue of hypoxia is something that has affected aviators for a long time. The F-22 had a challenge with it. The F-18 has had a continuing challenge with that as well. And other guys flying other types of airplanes talk about it occasionally. Talk to us a little bit about this system you guys have developed to try to tackle that problem.
Absolutely. So the Pentagon continues to investigate the root cause of these hypoxia-like incidents. We call them physiological events. Recently been experiencing and reported on F-18 and T-45 Navy platforms, but as you mentioned, F-35 is also in the news, and years ago F-22. One of the things that we're doing for the Air Force is we are developing and delivering sensors for them to measure what the pilot is inhaling and what the pilot is exhaling. We also measure the conditions in the cabin, so we have a very good understanding of what is going on, what's affecting the little pink body in the high-performance aircraft.
And do we have any, as I recall, when on each one of these incidents, the entire environmental control system's been disassembled, the entire, almost every part of the airplane has been disassembled as investigators have tried to find an answer. From the data that you guys are looking at, where do you guys think are some of the smoking guns?
It's too early to speculate. The Navy has said that the oxygen concentrator is working as designed. There may be some challenges with the bleed air, the quality of that air, but until we get these sensors fielded, and we've already delivered some to the Air Force, the Navy is getting their hands on a few copies as well, and when the exhalation block comes on next month, we'll have a much better understanding of what is going on in the cockpit, the quality of the air, pressure, temperature, and quality that the pilots are both breathing in and breathing out.
And tell us about how many of these systems are you guys deploying around the force in order to gather that data?
Well, right now it's a science technology project. It's called AMPS, Aeromedical Pilot Sensor System. We believe that these sensors, though, can be the foundation for a next generation life support system.
And you guys have concentrated on that. What is the state of the art that you guys think? You guys are always looking out there. You are innovators in aerial refueling, a whole bunch of fronts. Talk to us a little bit about where you guys think the state of the art on cockpit systems are going to be. A lot of investment, obviously, in the technology, but again, the pink body, has not had as many of the innovations that we've seen in other fields.
What we're looking to do with this next generation life support system is to be able to monitor and then predict and ultimately protect the pilots from these physiological events.
Greg, thanks very much for taking time with us.
You're very welcome, Vago.